Good day, everybody. My name is Glenn Stafford. Today I'm going to provide you an overview with the LEAPP command line interface tool that is provided by Red Hat. This allows you to migrate an existing RHEL 7 to a RHEL 8 server without having to do a redeployment, which means installing from the ground floor up the operating system and then the applications. We're going to especially hone in on the offline solution. This is critical to those environments that work in secured environments. For example, if you have a server in a secured DoD network, you're not allowed to talk to the outside world, thereby which a subscription to Red Hat is not a viable solution. Therefore, we're going to take a look at how we use this offline solution to do this migration locally. The objectives for this presentation include looking at why we need to upgrade, look at the basic LEAPP in place process, and then we will demo the manual steps to perform the necessary in place upgrade with the offline solution. So why upgrade? To begin with, RHEL 7 is in maintenance mode only. We are currently at 7.9. There's no intentions to go to 7.10. Only critical and severe updates will be made available as approved by Red Hat. Finally, RHEL 7's end of life is for June 30th, 2024. Effective July 1st, 2024, RHEL 7 will no longer be supported. The basic LEAPP upgrade process involving the installation and configuration of the environment, in addition to running the LEAPP pre-upgrade process for analysis, and then when we have a clean report, proceed with executing the directive LEAPP upgrade, involves the following steps. First, we need to consider a backup strategy. If you're a virtual environment, chances are very good that a snapshot of the environment is probably your best solution. If you're bare metals, you need to take into consideration in backing up specific directories and file systems that you can copy back if there are failures. Nevertheless, it involves testing the solution. Typically, if you have your system partitioned correctly, that you have your databases and applications in add-on environments, that should be enough to keep the LEAPP upgrade process from perhaps corrupting those areas. Then we need to install the LEAPP-related RPMs. In addition to the LEAPP RPMs, you will need to take a look at installing HTTPD, and the reason why, for the offline solution, we're going to use a web interface tool locally using HTTPD services, of which we will reference the localhost, which is the internal loopback at 127.0.01 as far as an IP address. Then we will copy the required data files to /etc/leap/files. The first one that comes to mind is the tarball file known as leap-data14.tar.gz. This file has 4 files that need to be extracted and placed into this destination directory. In addition, we will need to copy over a repo file to this destination directory. Some of you may be having red flags bouncing in your head saying, wait a minute, repo files belong into the directory yum.repos.d under /etc. That is true in your local environment. However, be advised the offline documentation that Red Hat provides specifically states that this repo file must be staged in /etc/leap/files, and we'll see the example of that when we run the manual process. Once we have everything configured, we're ready to go with the LEAPP pre-upgrade process. Once that command is done, we will review the analysis as far as looking at those errors that are being reported. Typically, we want to look at inhibitors. There are hard stops or showstoppers that will not allow you to upgrade until you fix those inhibitors. Then we do the remediation based upon the solution that we determined. Then we go ahead and rerun the pre-upgrade analysis. If there are errors, we do the review analysis again, do the remediation, and continue to cycle through between pre-upgrade process. There's errors, review the analysis, remediate. Once we have a clean report from the pre-upgrade analysis, we can proceed with the upgrade. We are now going to take a look at the process of doing this manual installation of an offline upgrade. Whether you're using an offline or subscription approach, be advised that your release level must be RHEL 7.9. If you're 7.8 or earlier, you need to do the necessary yum updates to bring the server up to 7.9. To verify that we're at 7.9, I'm going to display the contents of Red Hat-release. And when we go ahead and execute that command, we can see that we happen to be at 7.9. Now we're going to list the contents of our staging directory known as /addon/leap build. You can use whatever area that you want to use to stage the files. This was the path that I chose for this particular system. Here we have these three files. The leap-data14.tar.gz happens to be a special file. This tarball we extract 4 particular files from that we'll see shortly and place them into the /etc/leap/files directory once the Leap software is installed. Excuse me. Next we have the leap_upgrade repositories.repo file. That will also be populated in the /etc/leap/files directory. And then we have the ISO image that we're going to mount to be able to have access to the RHEL 8 packages. And this particular DVD happens to be RHEL 8.4, so that's release 8.4. If we take a look at the contents, notice these 4 files. One is a CSV file format of repo map. The next are these .json files that are referenced by the leap command to be able to do its magic in building an 8.4 server. If we go ahead and take a look at the repo file, what is very interesting in this particular configuration documented appropriately by Red Hat is you're going to create a local host web-based server to reference the appropriate Red Hat 8.4 packages. We'll see how that comes into play when we do our magic in getting the HTTP product installed and configured. Let us proceed with installing the HTTPD software. What you should notice that in addition to having the HTTP software installed, we are going to have a dependency that happens to be installed. Then we'll go ahead and load or install the LEAPP package with its dependencies. You can see the 4 files that were installed, which are right here. And then we have the 4 dependency packages that needed to be installed. Now we need to make the directory that we're going to mount the ISO image to. Under RHEL 8.4 is going to be your BaseOS and AppStream repositories that have the RHEL 8.4 packages. Now we'll go ahead and mount that file system, and it's successfully. Don't worry about this message from mount. It's just telling you that this is a write protected. It's a read-only file system, which is typical of your ISO images. We'll go ahead now and enable HTTPD. This is going to be controlled, as you know, from systemctl. Next, we will go ahead and start the HTTPD services. We don't see any error messages. However, to confirm, we can check the status. So now running systemctl status HTTPD, we see that it happens to be active and running. As an additional health check, we can run the curl command and notice the URL that we provide where we're referencing the repomd.xml file. This is going to be under /var/www/html/rel84/baseOS/repo data, and there in that directory is repomd.xml. We didn't get any errors. We have a lot of output. You may consider that to be too busy. That's why I have a preference to using the -I as in India as an option, because it gives you a summary, and all we need to do is take a look at the fact that we got a return status of 200 OK. We're good to go to proceed with the LEAPP pre-upgrade. The LEAPP pre-upgrade is where we will do our analysis to see if there are any issues that we need to reconcile. We're basically looking for inhibitors, because inhibitors are basically hard stops or showstoppers, however you want to look at it. What's worth mentioning is, notice since we are doing an offline pre-upgrade process, we need to include the option tac no tac RHSM, which means we are not using the Red Hat Subscription Manager. Then we have two additional arguments being provided, and these arguments are saying you need to enable BaseOS and AppStream. It will know where to go to based upon the information that's based in the repo file. We will now go ahead and execute this, and we will return after LEAPP pre-upgrade completes processing. Welcome back, everybody. As you can see, we have some issues here, and the clue here is the path name for this file. It is stated by the message that this is either an invalid file or could not be retrieved. Chances are pretty good that we, Glenn, being myself, screwed up, and we need to fix that. And we can see how we fix that in a moment. I wanted to show this error because this apparently is a common step that's missed by people, thereby which if we go ahead and extract the file, which we're going to do with the tar command, we're going to get these 4 files to put them in etc LEAPP files. The article on this, by the way, is this URL that you want to pause the screen and write this one down to be able to reference the article. I periodically take a look at this article to see if the tar file has changed. When I first started the testing for LEAPP, we were at leap-data13.tar.gc. Since then, leap-data14.tar.gc became available. This article tells you what the most current tarball file happens to be. In order to reference this article, you need to have a valid subscription with Red Hat. We'll go ahead and tar the file, and if we take a look at the directory, we can see that we have those 4 files in the /etc/leap/files directory. I also say that I missed a step, which includes getting the repo file into this directory. I'm going to copy the repo file over to /etc/leap/files. Now, you might have been thinking about this beforehand, and that is repo files belong in /etc/yum.repos.d. If you read this solution article on how to prep your machine for an offline solution, it specifically states that the repo file must be staged in /etc/leap/files. If you put it into etc yum.repos.d, it will not work. We go ahead and make that copy. Now again, we can go ahead and do the LEAPP pre-upgrade. And if you recall, we are doing analysis to see if there's any inhibitors that are going to stop us from being able to proceed with the upgrade. We'll go ahead and launch this command, and we will return after it has completed execution. Welcome back. As you can see, we happen to have some issues. And I'm going to reposition this screen so we can see it. And what's important here is what has happened. And we can see that we have two inhibitors. One deals with TCP wrappers. One is dealing with a missing answer that needs to be resolved. These are very generic when they're listed. This is one of the reasons why it becomes very important that if you want to see the details, it will be in this leap-report.txt. And that file resides under /var/log/leap. This is a neat little awk script that I have used in past where I know that there's the inhibitor, and so from the inhibitor until I get these dashes, I'm going to take a look at what the text happens to be, and these happen to be the two inhibitors. What is interesting in the inhibitors, it is talking about two files that are an issue with TCP wrappers. Now, if we understand the etc host.deny and etc host.allow, it basically has rules dealing with specific processes and what servers or computers can access that information, as well as perhaps users. The next one, we can see that we have something missing involving the answer file. So they want you to manually edit the answer file, and basically it deals with this confirm equal true. You can use this leap answer section, or you can actually just modify the file. Now, having said that, we are going to update etc host.allow and etc host.deny. But first, we're going to take a look at the contents of this file, and here are our entries. These are the active entries that exist. We need to basically disable them. Same in host.deny. So here's my edit command, and you'll know that this is a nice little facility taking advantage of bash. I have vi/etc/host dot, and then I put inside curly braces allow, comma, deny. It's going to basically edit those two files. I'm going to come down here, and a good systems administrator technique is if I disable these entries, I'm going to use my initials so other systems administrators know who to come and see to question why I did that. I'm going to write that change. Now I'm going to go to host.deny, and I'm going to repeat that step, and now I have those changes. Just as a little spot check, I use the grep command to see if those entries are disabled, and I see that they are for host.allow as well as host.deny. Now I'm going to cat the varlog leap answer file, and this is the issue right here. If we take a look, we have a #confirm equal. That is having confirm disabled. We need to be able to set that to true. So available choices are true or false. We'll go ahead and set it to true. We're going to use the sed command, and basically for those unfamiliar with sed, this is the match that we have, #confirm equal. We're going to replace that with confirm equal true. The nice thing about this sed command, we can use the -i option that allows us to interactively edit that file. We provide a .bak because that will create a file called answerfile.bat. So that way we have a backup copy. We execute that command. Now we'll confirm that we have an active entry. And sure enough, we have confirm equals true. So that's extremely useful as far as getting that done. We go ahead and now run the LEAPP pre-upgrade command. We're still going to be consistent with our options. TAC no TAC RHSM for no Red Hat subscription. And then we're going to have the BaseOS as well as the AppStream enabled, which will be referenced by LEAPP from the repo file. We go ahead and execute this command. We will pause the video and come back when it's done executing. Welcome back. As you can see, we have green for the report. This indicates that we happen to have a successful LEAPP upgrade. Or I'm sorry, as you were, we have a clean LEAPP pre-upgrade report. This will allow us to go ahead and proceed with the LEAPP upgrade process. First, it's worth taking a look at grub CFG. This particular command is being piped to word count to see how many menu entries we have. And if we grep for those menu entries, you can see that this server has the 7.9 kernel to boot off of, and then the rescue mode. So these are the only ones. What's going to be interesting is to take a look at the grub.cfg once we have a successful execution of the LEAPP a successful execution of the LEAPP upgrade process. Notice that the commands here for LEAPP upgrade or LEAPP pre-upgrade use the same options. So the only difference here is the directive. We've changed this from pre-upgrade to upgrade. However, our arguments are still the same in that we indicate that we're not doing a Red Hat subscription, along with enabling the BaseOS and AppStream repositories through referencing the repo file. We're going to execute this command, pause the video, and come back when it is done executing. Welcome back. As you can see, we're in the green, which means we've had a successful LEAPP upgrade process. However, this is your proof. Notice that it created a init RAM disk. When you see that message, you know that the LEAPP upgrade process was successful. Now, next what we want to do is take a look at the following. We're going to look at the menu entries as we talked about in Grub. We used to have 3, we now have 2 entries. And when we take a look at the entry, notice that we have this RHEL upgrade init RAM file system. This is the default parameter to boot off of. We boot off of that RAM file system. It will mount the disks to be able to do the necessary magic to do the upgrade. That's basically critical there in terms of what's happening. Now that we have completed this information, we need to take a look at a few things. First, I want to change directory to /var/log/leap. And we're now going to take a look at the contents of this directory. And what you will see here is an archive directory that basically has information from previous runs. So if we do an ls on archive, you can go ahead and see that we have 3 files. And if we were to just, for the heck of it, take a look at one of these files, I'm going to just do a tf on archive, and then I'm going to grab one of these files and paste that name. We can see the contents. Notice that we have the LEAPP report.txt file there. Now we're not worried about that. We're going to just go ahead and take a look at the existing LEAPP report. So we will go say vi leap-report.txt. And what is worth mentioning here is here are specific pieces of information. We have a high with risk factors, and we just basically need to review these to see what corrective action, if anything, that we need to take. So definitely you're not out of the woods. However, it's a good idea to take a look at that. This is going to be the interesting aspect. Notice that we are set to permissive mode with SE Linux. If we were to quit out of this and say get enforce, notice we are in fact permissive. This is probably required in order to be able to do the necessary building of the RHEL 8 platform. What will be interesting is when we're on the flip side and take a look at whether or not it is permissive or in enforcement. Next area that I want to take a look at, because this is a good habit to get into as a systems administrator, I'm going to change directory to /addon/leap tools. I happen to have 3 scripts here. If you notice, I happen to have a builder directory, and there's basically nothing there at this time. However, I'm going to do a cat on the boot tree list. And what you will see here is I'm going to basically grab the cat release, display the contents, but I'm going to print positional parameter 1. We're going to go ahead and first grab this so you can have an appreciation of how this works. First, I'm going to stick in a £, and then I'm going to stick that command. And what I'm first going to do here is I'm going to say we're going to cat Etsy release. Here we are at 7.9. Notice what I said, NF-1. So this is the last field. I'm going to subtract, I'm going to go there. Thereby which, if I go ahead and run that command, lo and behold, I get 7.9. Now the interesting aspect, what this is going to do is assign 7.9 into this particular release variable. However, I'm going to echo the release variable to set, and I'm going to say replace the period. Now a period is a regular expression special character that says match any character. We use the backslash to take away the special meaning, and then we replace it with the hyphen. let's go ahead and from this particular boot tree list, I am going to go ahead and run this command, and notice what we're going to have happen here. We're going to create a file called boot tree release, and it's going to have the release number. So if I say shell boot, and you'll notice that it echoed 7.-9 because we replaced that period with the dash. If I do an ls until the builder, if I can type, there we have the 7-9. This is the boot tree list if we want to take a look at it, because notice one of the things that we did here when we were looking at this particular file, we were going to use ls minus uppercase R to do a recursive search. Thereby which, if I go ahead and say more tilde builder slash boot, and look at this slash boot, it lists all the information underneath there. Just gives me nice little information. I'm using this file as this is what the boot file structure system looked like when we were 7.9, and we may have to compare that to what the boot directory is going to look like when we are at 8.4. The next thing that will be helpful is let's go ahead and cat RPM query. Here you'll see that we are going to, with the query format, grab the name, the version, the release, the architecture, the package ID number, the vendor, as well as the install date type. Now this will look busy, however, the important thing to know, I want to be able to have this table so if I have to do any troubleshooting and need to compare between 7.9 and 8.4, I have that capability. As a result of doing this, I'm now going to type in sh to execute that command. You'll see that the version came out. Now, if I go ahead and take a look at my more, or actually first, let's go ahead and just say ls tilde builder, and we're going to say just list the directory. We see that we have the RPMs underscore 7-9.txt. If I go ahead and do the necessary viewing of that file, specifically speaking, what I'm going to do is change ls to more, and then I'm going to append RPM, and here you can see this file. Now it's busy, however, this is a pipe separated field, and you can see some very pertinent information. You can see how for the vendor I have Red Hat incorporated. This is a good way if you ever need to check to see if you have any third-party packages that you may have missed in being able to install on the 8.4 server, because there's a good possibility that there are going to be packages removed by the LEAPP process. Red Hat specifically states it's only responsible for the Red Hat packages. It's not responsible for your third-party packages. That's why what's worth considering is maybe before you launch the LEAPP upgrade process, you go ahead and remove those packages. Then when you get to the 8.4 side, you can go ahead and reload those packages and have, hopefully, a functional system. Now, some of the prohibiting factors here that you need to take into consideration, your server needs to make sure that you do not store your databases, your application files under /the root or /user. Typically, you should have an add-on directory /opt that facilitates your add-on applications as well as those directory structures for your database. That's just food for thought in that particular area. The next one that I want to take a look at is we'll go ahead and cat the services list. Here, we're going to build a service list by basically using the system control. We're going to say list TAC units, TAC type equals service. If we execute that, we do an ls minus L on tilde builder. We see the long listing of that particular file. We can go ahead and say, I want to change word. I'm going to have to do more. And I'm going to need to get rid of this character. And then I'm going to say capital S service list, and it expands to that. And here you can see the system control files that have been loaded to take on the various servers. Let me repeat that. You can see which system control files are loaded in terms of the services that is currently happening. So this is a good file, inventory file to have. In essence, what we're basically doing here, which is a good administrative technique, I'm going to list the basic listing of the builder directory. We have a boot tree list. That is the tray structure of what /boot looks like for 7.9. We have the RPMs inventory for 7.9. We have the services list that shows us what's been loaded through the systemd environment. Now, an interesting aspect here I'm just going to do is I'm going to do a word count where we get the number of records. That's why we use the minus L option or TAC L. We're going to expand builder and we're going to say RPMs. Notice that we have 711 entries. If I were to do an RPM minus QA and pipe that to word count minus L, we have 711. So the number from what is in the RPMs file and what RPM minus QA, excuse me, I got my tongue tied again, RPM minus QA pipe to word count minus L, I'll go ahead and have 711. So we know that the inventories match. The next thing we're going to do is a reboot now. When this is done and we're up and the system is available to us, we're going to take a look at what the 8.4 server looks like with particular pieces of information. We will proceed with the reboot. We will pause the video right now and return when it's done rebooting. Welcome back. We have completed the reboot. Prior to getting to this stage, there is two phases that takes place. One is that when it boots up, we have the init RAM file system booted off of. It does its magic in being able to build the disks for RHEL 8.4. Primarily, it's the root and user area that need to be updated with RHEL 8.4. Then it will reboot. That will bring you to a state that you can now access the system. To see where we're at, if we cat /etc/red hat release, we can see that we are now at 8.4. So we've had a successful build. I'm going to change directory to /addon /leap tools. And if you recall these areas, what we're going to now go ahead is run shell boot tree list. We We see 8.4. We're going to do the same for RPM query. I'm not sure why it is not allowing me to do the tab expansion. We'll just go ahead and execute that. We see 8.4. I'm going to set my editor. Maybe that's the reason why I can't do tab expansion. I'm now going to go ahead and say shell. And I'm going to put in ser, see if that expands. Nope. So we'll do services dash list. And that provided 8.4. So now if we take a look at what is in the builder, we can see that we have the 7.9 and 8.4. Interesting enough, let's just go ahead and change directory to builder. And I am going to take a look at a couple things. I'm going to do a word count minus L on RPM's 8.4.txt. We come back with 958 records, which means this has 958 RPMs installed. If I were to do RPM minus QA, and I pipe that to word count, and I get a record count with the TACL option, I get 958. If I were to want to take a look at what the services were, I'm going to say word count minus L, services, and I'm just going to use a asterisk to say match 0 more characters. And we had 57 services in 7.9. We now have 54 services. So again, we probably might need to take a look at what those differences happen to be. And then what will be interesting here is if I do word count minus L on boot, we'll notice that the 8.4 shows 69 entries. We're not sure what the differences will be. However, if I were to say history and pipe that to grep menu entry, you can see I have my grep command, and I'm going to see what my menu entry looks like. And you'll notice nothing got returned. And that is because the structure of boot has changed. And thereby which, I wonder where this stuff may be. Well, I can perhaps do find, and I will say /boot, and I'm going to look at those things that are files. That's why I do a tac type F. And then I'm going to pipe it to xargs, and I'm going to say grep, use the minus L to list the file names, and I'm going to look for menu entry. And here you can see the different files. Now, what might be beneficial here is maybe taking a look at what those files are to make sure that they're not binaries. So now I'm going to say find, and then I'm going to then pipe this to xargs file. And we can see that the grub x64 is an executable program, so that's an executable program, so maybe we need to take a look at what these two specific files have. Now, again, notice that we used to look for this under /boot/EFI/EFI. Notice that there's no longer a, well, I'm sorry, let's backtrack on that. So here's the boot EFI Red Hat grub. Now we have the grub saved. So what did they basically do differently? Or more or less what I'm going to try and do here, just from experience, I'm going to go ahead and say find /boot, and I'm going to say minus type F, and then I'm going to say grep minus L 11, or maybe I should say 1060, because 1060 is the 7.9 kernel. No such luck there. I'm going to think about this for a moment, so let me pause the screen while I do some exploring. Welcome back, and I think I might now have an answer in working with this, simply because, again, 8.4 has some really significant changes, and it's probably a good idea to be able to take a look at how this differs. To begin with, I'm going to go ahead and type in find, and I'm going to say /boot, and I'm going to say minus type F, and I'm going to, just for the heck of it, pipe this to xargs, which is a command generator, and I'm going to say grep minus L, and I'm going to say 1160. I screwed up before where I said 1060. 1160 is the latest kernel number that I can match off of, and you can see the files that come here. Now what's really interesting is this bootloader entries. So I'm going to go ahead and copy that, and now I'm going to say cd to that directory. I'm going to list the directory, and notice that we have 3 files. And what I'm very intrigued with is, notice the naming conventions, EL7 for that one file. We got 3.10.0-1160. That is probably referencing the 7.9 kernel. Notice the EL8. It has 4.18.0-305 EL8. So that happens more than likely be the information for the most recent kernel for 8.4, or actually the kernel that came from the information when we loaded off of the ISO image. If we go ahead and cat this particular file, because you'll notice that it all has the same ID, not sure how that works, but what I'm going to do is paste this, and we can see we have information on how this information gets loaded and makes all the references. So even though we do have a grub CFG, all the bootloader information now happens to be under this directory /boot/loader. If we were to change directory and perhaps change directory to ~builder, so I'm going to change directory to ~builder, and I'm going to list this directory. What I'm going to do is vi boot tree list. So I want to look at this file, and I want to see if I can find loader. And notice that I have loader. I'm going to look for the next occurrence of loader, and there is bootloader entries. If I go down to bootloader entries, there's nothing there. So this is kind of interesting. So under 7.9 it was not there, although that directory existed. However, now if I do the same as far as bringing this thing up, as far as this text file, and I'm going to do a change where I'm going to say 8, and I'm going to do a 4, or I'm goofed that one up. That's going to be 8-4.txt. And now I'm going to go to loader. I'm going to go to the next occurrence of loaders. Notice I have entries, and there's information there. So we can see that we probably will need to get up to speed with what has changed with RHEL 8.4. Hopefully, you have found this presentation useful on how we do a offline upgrade using LEAPP. Again, in summary, LEAPP is a command line interface tool that allows you to do an in-place upgrade of a release 7.9 server to a release 8.4 server. We went through the offline steps for those who have the issue of, okay, how am I going to update this server because I cannot do a Red Hat subscription? You know the documents are available to you for this, and if you have a subscription, create a case ticket if you want Red Hat to provide you some additional information as to where all these documents are at that will help you. This concludes the presentation. Give me a like if you thought this was a worthwhile presentation to view. Take care and happy Linuxing. Let us summarize what we covered today. First, we took a look at why we need to upgrade. As stated, right now, RHEL 7 is only in maintenance mode, which means only critical and severe updates as approved by Red Hat will be made available to its customers. In addition, effective July 1st, 2024, RHEL 7 will no longer be supported. Then we took a look at the basic steps of the LEAPP in-place process specific to the offline upgrade. Remember, if you do not have the ability to talk to the outside world, specifically having a subscription active with Red Hat, you need to do the offline process where this build takes place locally. This will involve having a repo file that will be copied to the /etc/leap/files directory. And then we would do the necessary mounting of the ISO image when we're ready to run the LEAPP pre-upgrade and upgrade processes. But prior to that, keep in mind, after we have executed the steps of installing the LEAPP-related RPMs and dependencies in addition to HTTPD, we then update etc LEAPP files with, again, the repo file that references the locations for the AppStream and BaseOS repositories. We also extract the 4 files from leap-data14.tar.gz that is staged in etc LEAPP/files. This provides the pertinent information for LEAPP to do its build process. Once we have that all in place, we have HTTPD enabled. In addition to now starting the services, we can go ahead and run the LEAPP pre-upgrade process. You are going to basically look at what are the inhibitors that need to be fixed, and it gives you the appropriate recommendations that you will find in the LEAPP report.txt file under /var/log/LEAPP. The information that gets spewed to your terminal may not be sufficient details. That's why you need to take a look at that report file to go to the specific areas. Then, when we take a look at, we demoed the manual process, and during the manual process, when we did the LEAPP pre-upgrade, we saw 2 issues. One, we needed an update and answer file where we had a confirm equal true. Second, we had active entries in host.deny and host.allow where we commented those entries out, and as a result, we ran pre-upgrade process again and had a clean report. Now, be advised, in the demo, we had the ability to do a LEAPP upgrade successfully. However, you could run into some issues that especially if you have add-on RPMs that are not part of the RHEL or Red Hat distribution that might have incompatibilities of which you will then need to remove those packages. The best thing to do, if you have the resources available, create yourself a virtual environment with your specific application server and test out the build server capability of doing these steps as demoed in this video and see if you can have a successful upgrade. I will mention this, that in certain shops where they had their own add-on repositories that were independent of the Red Hat distribution, there were a couple packages that were incompatible with RHEL 8. It told you to remove them. In this scenario, if you have your applications being installed on an add-on directory, perhaps the best approach is to go ahead and remove all those packages before you do the upgrade process. And then when you finally get to 8.4, install those RPMs of your add-on packages that are compatible with RHEL 8 and do your necessary regression testing to make sure that everything is fully functional and operational. The caveat that I will point out, you may want to take a look at what your configuration files are and back them up into a tar file and save it in a safe location, so then once you are upgraded to 8.4, you copy your add-on packages and you do the necessary install. Then you copy back your configuration files, and hopefully you will have a fully functional system that you successfully test and can proceed in your RHEL 8 environment. Again, the other thing that we probably should mention, it's probably in your best interest, any data files or databases, they should probably be on a separate file system that's not part of the root file system / user file system. It should be an add-on file system where your mission critical applications that you built yourself would reside. Hopefully you found this information to be beneficial. Feel free to reach out to me if you have any questions or comments. If you want to reach out to me, you will notice my email address, stafford_g@billsouth.net. Please, in the subject matter or subject heading, indicate LEAPP. That way, if your email by chance goes into my spam location, I will know to move it to my inbox so I can read and respond to it. I hope you found this information extremely beneficial. I am not going to say that LEAPP is the actual answer to your solution to upgrade from RHEL 7 to RHEL 8. Nevertheless, it's worth investigating and testing to see if this is a viable alternative as opposed to doing a redeployment from the ground floor up. I will admit that with today's commercial off-the-shelf products such as Ansible, you may be better off building a server from scratch. I don't know the answer. However, this particular feature that Red Hat provided was for the benefit of those that could not afford to do a redeployment based upon all the steps that were involved in creating the users and having the build the data. You know the drill. Nevertheless, I appreciate you viewing this video. Let me know what you think about it, and I look forward to being able to provide other tutorials that you may find beneficial. Have a great day.